the State of DevOps report. I hope you've read it by now, and that's okay if you haven't. I'm not a judgy person. If you haven't had a chance to read it yet, that's totally fine, but please do go and check it out. You can download it there at that bit.ly link, bit.ly/DORA-SODER, State of DevOps report. Okay, so DORA, as you know, as you may know, is an ongoing research program that's been around for about 8 years now or so. And we research into the capabilities and practices that predict the outcomes that we consider central to DevOps, namely software delivery performance, operational performance, and importantly, organizational performance. So how do we measure software delivery performance? Essentially, we think about two big characteristics when it comes to software delivery performance: the throughput of your system and the stability of the system. So we use these 4 different metrics: 2 for throughput, that's the deployment frequency and the change lead time, and 2 for stability, that's your change fail rate and your time to restore service. As you may know, the practice of DORA and the practice of our research is to go out into the world and ask people lots and lots of questions. This is how we gather our data. We use survey methods. And the question specifically that we ask about your time to restore service is this one. For the primary application or service that you work on, how long does it generally take to restore service when a service incident or a defect that impacts users occurs? For example, there's an unplanned outage or some sort of service impairment. And we give our respondents answers like you see on the screen here. So they get to pick a bucket in that. We have been consistent with this question over the years of the research program, going back quite a few years. As I mentioned, the research program has been around for at least 8 years. We've been asking this question pretty consistently every single year. And when it comes to software delivery performance and those 4 software delivery metrics, what we do is we gather all of the information from all of our respondents. We throw that information down onto a plot, all 4 of these answers together, and clusters emerge from the data. We use that cluster analysis to understand what are the performance characteristics of various teams across the industry. Because this is a survey that's open to the world, we get respondents from every industry vertical, whether it's financial services or retail, government, technology, and organizations of every shape and size. So 150-year-old banks with 2,000 developers, 18-month-old startups with 4 developers, 4 employees altogether. They all participate in this study. And what we've shown year over year when we look at software delivery performance, there is not a trade-off between speed or throughput and stability. Maybe we think that there is, but we see that these metrics typically move together in lockstep. We can drill in or zoom in a little bit on the time to restore service. When it comes to these clusters, we use the median value within the cluster that appears. Now, I'll be the first to admit, I'm not a PhD researcher. I am not a statistician. My job typically is to help people interpret and learn from this data. But don't worry, we have statisticians and PhDs on the call that can help us dig a little bit deeper. Let me just keep going though a little bit more about the research. So for the past couple of years, we've looked beyond just software delivery and into reliability as well, or operational performance. And this is because we all know that delivering software is, it's one step along the life cycle of a piece of technology, of a service that we're using. In fact, our users don't get any value out of that service until we've delivered, but then they get continuing, ongoing value through our operational practices. So we've introduced another sort of key metric that is reliability, but reliability itself is a multifaceted measure. It helps us understand how well a team is able to uphold their commitments to their customers. And in this year's report, we continued to explore reliability, and we use it as part of one of the factors, if you will, in our software delivery and operations performance metrics. And it includes our research into reliability includes questions around things like, are you doing regular reliability reviews? Are you reprioritizing work? And importantly, how often do your services meet the reliability expectations that you've set for them, or more appropriately, that your users have set for them. Now, look, when you take all of these metrics, our process uses survey data. We go out and we ask people questions and we get their information. But think about some of these metrics. They're in our systems. We can build tooling that will give us dashboards and show us exactly what's happening. And many people are doing that across the industry. Even our own research team, the practitioners here at Google, working together with the community, we have an open source project called, well, it's called the 4 keys. It's measuring those 4 keys of software delivery performance. And in that, of course, we look at the time to restore service. You can learn more about the project on GitHub. One of the key things here, though, is that the M in the MTTR in this particular implementation, we're looking at the median, not the mean. So we're not looking at average, we're looking at the median value as we sort of visualize this and raise it up as part of the 4 keys. Now, another quick thing I'll say about those 4 keys, we aren't really expecting teams to look at those 4 key metrics as 4 distinct values. It's really looking at the conglomerate of them all can help us get a better understanding of how we're doing. All right, so we're here today not to talk about the 4 keys. We're here today specifically to talk about time to restore. So time to restore is being used as one of those 4 key measures, but it doesn't really play a role necessarily in our operational performance. It's a measure that served us well, but maybe, just maybe, it is time to replace this metric. So around the time that the 2022 report was coming out, Amy Toby, who's here, thank you, Amy, for joining us, sent this tweet out. Amy, do you mind coming off mute and reading your own words aloud? We'd love to hear your interpretation of them.
So I addressed Jez and David Stanky because I know them a little bit. Can we have a chat sometime about replacing MTTR and the DORA report with something else, or at least add clear language about MTTR's shortcomings? This is becoming a problem as various companies try to productize the DORA assessments. Yeah.
Yeah. Yeah.
And there was another tweet like right around the same time I made specifically at a vendor who is selling a product. So like that was kind of what drove me into it.
Excellent. Excellent. Thank you. Thank you for that beautiful background. But shortcomings of MTTR, what possibly could you be talking about? Well, as it turns out, of course, there are a lot of people that think very deeply about metrics and the things that we're learning, the things that are helping us as teams and organizations improve our overall performance. And so I rediscovered recently this blog post from 2018 from John Allspaw. And in this blog post, I found some really fascinating things, kind of a new exploration or a deeper dive into MTTR. And I love the framing here. How can we learn about how decisions were focused, how escalation manifested, the impact of ambiguity when we're like dissecting an incident that happened, something went wrong? How can we learn about those things from things like MTTR or the frequency of incidents? Well, and if this isn't clear enough, let me just demonstrate. And in order to demonstrate, we're going to have some grapes. So check out these grapes. This bunch of grapes is 5.6 inches across at the widest point. The mean diameter of these grapes is 0.73 inches. I'll take issue right away with John. He should have looked at the median. No. The median color, though, I don't understand why he got median color, but mean, anyhow. The median color is 195, 211, 86 when you break it down by RGB or red, green, blue. So given these numbers, how do these grapes taste? Well, let me tell you. They taste delicious. All right, so look, John goes on, and this was one of my favorite quotes from the blog post itself. This is all valid data about these incidents, but they tend to generate very little insight about these events or what directions a team or company might take in order to make improvements. John is not the only one who's discovered this or is dug into this. There's certainly lots of writing on the subject all around the web. You can find the trials, the troubles the dangers of things like MTTR in many places. So that's what we want to discuss today.